Yellowstone National Park has recently experienced a significant increase in seismic activity, with approximately 200 earthquakes reported in the past 2 weeks. This unexpected spike in seismic events has raised concerns and prompted questions about what might be causing it. Could this be an indication of a major volcanic eruption on the horizon? Are these tremors a message from nature, and what implications do they have for the surrounding communities in the park? Let's delve into these questions. In just the past 2 weeks, about 200 earthquakes have been recorded in Yellowstone. This sudden surge has caused alarm, even though earthquakes, tremors, and hot geysers have always been part of Yellowstone's dynamic landscape. The recent rise in seismic activity is particularly troubling. Speculation about a potential large-scale eruption has been fueled by a warning from a park official. Yellowstone's geological activity spans thousands of years, with Native Americans inhabiting the area for over 11,000 years. Systematic explorations by mountain men began in the early 19th century. The park came under the oversight of Columbus Delano of the U.S. Department of the Interior in the late 1860s, with the U.S. Army managing it from 1886 to 1916, before the National Park Service took over in 1917. Covering an area of 3,468 square miles, Yellowstone is home to rivers, lakes, canyons, and mountains. One of its most famous features is Yellowstone Lake, one of the largest high-altitude lakes in North America, sitting atop the Yellowstone caldera, the largest supervolcano on the continent. Given the recent seismic activity, there is always a possibility of a significant volcanic eruption. Yellowstone is the heart of the greater Yellowstone ecosystem, one of the last nearly intact temperate ecosystems in the Northern Hemisphere. This vast wilderness boasts diverse geological features, deep forests, rare creatures, and a wide variety of plant and animal life. In recognition of its ecological significance, Yellowstone was designated a UNESCO World Heritage Site in 1978. The park is also home to many historically and architecturally significant buildings. Nearly 1,000 native archaeological sites have been studied, revealing the complex history of civilizations that lived in the area. Beneath the park's tranquil surface lies a vibrant ecosystem, home to hundreds of species of amphibians, birds, fish, reptiles, and mammals, some of which are endangered. The park's natural beauty is enhanced by its large meadows and woodlands. Yellowstone is known for its iconic species, including grizzly bears, cougars, wolves, and herds of bison and elk. It hosts the largest and most famous public bison herd in the contiguous United States. Yellowstone's annual forest fires, which shape the landscape, are another example of the powerful natural forces at work. The 1988 fires permanently altered about a third of the park. Despite these challenges, Yellowstone remains a haven for outdoor enthusiasts, offering year-round hiking, camping, boating, and fishing opportunities. Our focus now turns to Yellowstone's geothermal wonders. The park's fiery core fuels a remarkable array of geothermal activity beneath the surface. With approximately 10,000 thermal features, including geysers, hot springs, mud pots, and fumaroles, Yellowstone stands out as a unique and dynamic natural wonder. Researchers in 2011 identified 1,283 geysers in the park, about 400 to 465 of which are active annually. These geysers are concentrated in 9 large basins, with a few scattered across smaller thermal zones. While most of Yellowstone's geysers are modest, erupting only a few feet into the air, famous geysers like Old Faithful garner much attention. Yellowstone's hydrothermal system is powered by an ancient, active caldera. When subterranean water and volcanic heat combine, steam and boiling pools form, leaving behind mineral deposits like silica and travertine. Beyond its well-known geysers, Yellowstone hosts numerous other geothermal wonders. The park's diverse terrain is home to a variety of unique thermal phenomena. Microorganisms thrive in the thermal pools, creating colorful mats of algae and bacteria that are vital to the park's ecological balance and aesthetic appeal. Yellowstone's geothermal features are ideally located where Earth's surface conditions meet its energy. The best places to observe these natural marvels are in geyser basins, where precipitation and snowmelt sink into the earth and encounter extreme heat. These basins are usually found in valleys with flat bottoms, nestled between glacial remnants and old lava flows. The average boiling temperature in Yellowstone's high-elevation geyser basins is about 199 degrees Fahrenheit 93 degrees Celsius, highlighting the extreme heat below the surface. Geysers like Steamboat Geyser can shoot steam and boiling water up to 390 feet into the air when pressure builds up, cooling quickly as it arcs into the air to protect onlookers and nearby boardwalks from the intense heat. Artifacts found at Mammoth Hot Springs and other thermal sites suggest that prehistoric Native Americans had a close relationship with Yellowstone's geothermal features. According to historical tales, the hot water was used by early settlers for cooking and bathing. When 19th-century explorers began to document the area, stories of mystery and awe emerged. Father Pierre-Jean de Smet reported that the Aboriginal people considered these places spiritual battlefields, and locals warned explorers during the Lewis and Clark expedition in 1806 not to enter the crater due to fear of the spirits believed to reside there. John Coulter, a member of the Lewis and Clark expedition, ventured alone into Yellowstone and described its geothermal features as both mesmerizing and terrifying. Trapper Jim Bridger famously referred to Yellowstone as the place where hell bubbled up, a phrase that remains evocative today. Yellowstone's superheated brine, a saline mixture bubbling at nearly 400 degrees Fahrenheit 204 degrees Celsius, lies deep beneath the surface under extreme pressure. This brine powers the park's geothermal activity. The porous terrain of the Yellowstone Plateau allows the brine's hot energy to rise through the rock, creating breathtaking geothermal phenomena that attract tourists from around the world. Fascinating chemical reactions occur when fresh groundwater and deep heat combine. Silica, a strong mineral found in Earth's crust, dissolves and re-emits, forming an intricate web of closed channels. This process begins an amazing journey that spans thousands of years. When the superheated water finally reaches the surface, it erupts in a spectacular display of steam and splendor. Geyserite and Sinter, silent witnesses to this ancient dance, testify to nature's enduring power and the relentless passage of time. The Norris Geyser Basin, one of Yellowstone's most fascinating locations, is known for its intense geothermal activity. Situated at the confluence of three significant faults, the Hebgen Lake Fault, the Norris-Mammoth Corridor, and the ring fracture zone created during Yellowstone's early volcanic eruption, this basin is extremely active and hot due to these faults acting as nerve centers. The Norris Geyser Basin occasionally experiences abrupt and erratic activity, waking up suddenly and behaving unpredictably for weeks. During these periods, water levels, temperatures, colors, and patterns of geyser eruptions change. For instance, the Porkchop Geyser erupted continuously with water and steam in 1985, but silica buildup choked it, causing a catastrophic explosion in 1989. Intense bubbling resumed by 2003, with activity peaking later that year, leading to parts of the basin being closed for safety due to high temperatures. The convergence of these three major faults causes disturbances in the Norris Geyser Basin, with the ring fracture zone from the old volcanic eruption acting as a pressure cooker about to explode. Captivating displays of nature's power await, with hot water and steam imprisoned beneath the surface, ready to burst out. Abyssal plains beneath Yellowstone National Park are rapidly heating up, increasing pressure and producing steam. An explosion occurs when the pressure builds up too much. The Norris Geyser Basin, located atop a large amount of geothermal activity, is a popular eruption site. The thrill isn't just caused by the heat, the rocks below the surface also play a significant role. As hot water passes over these silica rocks, it interacts with the water, picking up silica particles similar to how trash clogs a drain. This buildup can choke the vents of geysers and hot springs, leading to pressure buildup and eventual explosions, like the Porkchop Geyser. You might wonder if authorities are warning about another blast. The answer is no. Instead, earthquakes pose a serious threat to Yellowstone National Park. According to the Yellowstone Volcano Observatory, YVO, there are 1,500 to 2,500 earthquakes in the area annually, based on seismic activity data from 1995 to the present, spanning 3 decades. Annual fluctuations in Yellowstone's seismic activity are significant. For instance, there were an incredible 3,427 earthquakes in 2017 compared to just 78 in 2011. What causes these earthquakes? Tectonic motions create tension, leading to earthquakes. Yellowstone sits atop a hotspot where intense pressure from subterranean volcanic activity and plate tectonic movement pushes against Earth's crust. When the pressure builds up enough, the rock near fault lines gives way, releasing stored energy as seismic waves. These waves ripple through the earth, causing the ground to tremble, which can be felt by anyone in the vicinity. Yellowstone's seismic behavior is distinct. While earthquakes are an inevitable byproduct of the active geological processes in the area, they serve as a reminder of the powerful forces at work beneath the park's tranquil surface. In Yellowstone, earthquakes are not random events but play a crucial role in the park's hydrothermal activity. Consider them as Yellowstone's natural means of maintaining a clear and efficient plumbing system. Without these sporadic shakes, small channels and fissures that supply hot water to geysers and hot springs could fill with mineral deposits. Interestingly, some earthquakes may even increase this activity. For example, the 1959 Hebgen Lake earthquake, a massive 7.3 magnitude event, and the 1983 Bora Peak earthquake, which measured 6.9, caused measurable changes in features like the Old Faithful geyser. This highlights the interconnectedness of Yellowstone's geology and seismic activity. As nature's cartographers, earthquakes help scientists explore the subsurface geology beneath Yellowstone's stunning exterior. Similar to how sonar is used to map ocean depths, scientists use seismic waves to study Earth's depths, aiding their understanding of the complex structure of Yellowstone's caldera and magma chamber. Let's examine June 16, 2017, at 6:48 p.m. Mountain Daylight Time, a critical moment in Yellowstone's seismic history. With a magnitude of 4.36 and an epicenter roughly 9 miles north-northwest of West Yellowstone, Montana, this earthquake was the year's largest. Nearby cities like West Yellowstone and Gardner felt its effects. This earthquake was part of a larger seismic storm, starting with the Maple Creek swarm on June 12, 2017, and lasting until October. Around 2,475 earthquakes struck the area during these months, with the epicenter located 6 miles north of West Yellowstone, Montana, extending to the park's western boundary. It seemed as though Yellowstone was having its own underground fireworks show, with nearly 3,000 earthquakes in just 3 months, marking the largest earthquake swarm ever recorded in Yellowstone. Seismic drama continued in 1985, 2009 near Lake Village, and again in 2010 between West Yellowstone and the Old Faithful area, with hundreds of tremors resonating throughout the region. What then causes these earthquake events? Scientists attribute the pressure changes and shifts to the circulation of hydrothermal fluids beneath the Earth's surface. The Earth moves in time with natural rhythms, like a volcanic dance. While we can monitor these forms and examine their trends, pinpointing the precise location and timing of their occurrences remains a challenging puzzle. You might wonder why, given that Yellowstone has been studied since the early 1970s, the range of normal seismic activity is based on data from 1995 to the present. The seismic network has evolved and changed over time. Before 1995, there were fewer monitoring sites in the Yellowstone seismic network. A significant upgrade occurred in 1995, with an increase in the number of stations and the technology they used, including new data transmission techniques. This improvement enabled scientists to detect and record more earthquakes, especially those with smaller magnitudes. Therefore, while it might seem that seismic activity increased in 1995, it was actually the result of better detection methods. Earthquakes with a magnitude of less than 3.0 on the Richter scale typically go unnoticed by most people. A magnitude of 4.0 or above is needed to start causing structural damage, while a magnitude of 6.5 is required to cause the ground to break. Although rare, earthquakes larger than magnitude 6 have occurred in Yellowstone in the past. Let's go back 57 years to one such event. On the night of August 17, 1959, in the Madison River Canyon near Hebgen Lake, just west of Yellowstone, around 250 visitors were tucked into their sleeping bags across cabins, resorts, and campgrounds. Just before midnight, the earth groaned, and an earthquake jolted the canyon, sending shock waves through the sleeping campers. The true nightmare unfolded next as a towering wall of water surged over Hebgen Dam, rushing down the river with unstoppable force. As if that wasn't enough, a massive section of the canyon wall collapsed near Rock Creek Campground, forever altering the landscape and the lives of those present. These earthquakes, according to Mike Poland at the Yellowstone Volcano Observatory, exemplify Yellowstone's unpredictability. He has observed earthquakes that rock the earth for days, weeks, and occasionally even months. A swarm beneath northern Yellowstone Lake in March of last year caused havoc for several days, resulting in multiple significant 3.0 magnitude earthquakes. Just this week, there were 2 major 3.0 magnitude earthquakes, the largest of 2023, in a noteworthy swarm. As we've seen, Yellowstone National Park is not only a place of breathtaking beauty but also a dynamic landscape shaped by powerful geological forces. From the smallest tremor to the mightiest eruption, the park's seismic activity reminds us of the incredible natural processes at work beneath our feet. If you found this exploration of Yellowstone's seismic phenomena fascinating, don't forget to give this video a thumbs up and share it with your friends. We'd love to hear your thoughts and questions, so drop a comment below and join the conversation. For more in-depth explorations of the world's most intriguing natural wonders, hit that subscribe button and ring the bell icon to get notified whenever we upload a new video. Your support helps us bring more exciting content to you. Thank you for watching, and we'll see you in the next adventure. Stay curious and keep exploring.